Hey everybody, Mr. MathWell here. I'm going to talk about the power rule today. In calculus, there are a number of really important rules. The power rule is one of them. If you're trying to find the derivative of a function or a term or a polynomial, you're going to run into the power rule a lot. So let's say we have a function f of x equals x to some power. This power is going to be a constant, okay? So some real number power. If we had something like this, let's just say y equals x here, okay? That's supposed to be a straight line. Y equals x. Well, I know what the slope of this line is because y equals mx plus b tells me that the slope is 1. That means because it's a straight line, the tangent line slopes, wherever I check them, will always be the same slope as the line. And so my y prime here should always be 1. Now, how do I use the power rule to figure that out? Well, again, if I've got y equals x, the power rule says this. This can be viewed as x to the power of 1. So to find the derivative, this is what you do. You take the exponent and you bring it down in front as a coefficient. Okay, that literally, see here's n, literally comes down and you just write it as a coefficient here. Multiply. And then what you do is you subtract 1 from the exponent that you started with. So that's where you get n minus 1, and that's now your derivative. Let's check to see if it works. So y prime is going to be, I'm going to bring this 1 down using the power rule because there's a power rule. 1 times x to the 1 minus 1 is 0. X to the 0 is 1. So y prime is 1. It means the derivative is 1 everywhere I would check, any x that I could check. Hey, that's great. So what about if I had something different? Like let's say I have y equals x squared. Okay. So y equals x squared, start over again. That's a parabola. I'm trying to get rid of some of this here carefully. Okay, it's a parabola that is origin centered there. Origin centered, has a vertex at the origin, that's what I meant. And this is x to the power of 2. Okay, let's use our power rule here and see what the derivative expression is going to be. So this is not going to be a constant when we're done. This is going to be an expression involving x, isn't it? And so y prime, use the power rule, 2 comes down, and remember this is a shortcut for all of your limit work, whatever we did limits in chapter 1. This is a shortcut for all this. And so I bring the 2 down in front and I subtract 1 from 2. So guess what? My derivative expression is 2x. It's that easy. What do you mean 2x? Well, what's the derivative when x is 0? That's the slope of the tangent line. Well, it should be exactly 0. So let's see, if I put in 0 in for this derivative, I'm going to go 2 times 0 equals 0. Hey, that checks out. What about if I'm doing x equals 1? Okay, well, what's the derivative evaluated at 1? Well, it's going to be 2 times 1, a slope of 2. So if we were to calculate that, you put that on your graphing calculator, and if you put a slope of 2 there for a line, it would fit just perfectly. So slope of 2. So that's how you do that. Now, a couple things I want to show you here as well. What happens if we already have a coefficient? Like what if we have y equals 4x squared? No problem. This 2 still comes down and multiplies by whatever is already there. So the power rule can also be written like this, and I'll just write it down here. The derivative of any function f of x. If the function has a coefficient already, then we got x to the n. And let's say we have a constant already in front there. It could be fraction, positive, negative, whole number, doesn't matter. Then the derivative is n times c x, and then this is still minus 1. So it just comes down in front anyways. So the derivative here would be 2 times 4x to the 1, or 8x now. Okay, so there you go. Let's do some practice. And this is pretty easy. I've got some practice questions here already laid out for you. A constant, right? It's 0. We know that from the constant rule, and we just actually, did I show you that? I didn't show you why that's true. Hey, why don't I show you why that's true? Why is the constant rule true, Mr. Maxwell? Well, let's say this was written in terms of x. Well, it's going to be x to the power of 0, isn't it? A constant can be written as 32, this constant, times x to the power of 0. So if I bring 0 down in front and multiply by everything, I have 0 times whatever, 32x to the negative 1. 0 times all of this is going to be 0, okay? It's going to be 0. So there's a slight technicality there. If x was 0, we'd run into mathematical problems. But the power rule still works. It's still 0, so the derivative is 0 of a constant. Okay. What about c? This is pretty easy. X to the 12, bring the 12 down as a coefficient, bump this 12 down one, boom, you're done. Simple as that. Beware with something like f, okay? What about pi? That's not a variable, that is a constant. So do the same thing. Pi comes down in front. Times x to the power of pi minus 1. It's okay to leave pi minus 1. That's a legitimate value. This is an irrational number. It's very exact already. So in calculus, do not round that, okay? Don't say 2.14159 or whatever. Just pi minus 1 is good, okay? J, okay, what if we have a fraction or something like that? No problem. Fraction comes down in front as the exponent. No big deal. The other tricky part here, you have to subtract 1 from the fraction. So 3 over 2 minus 1 would be the same as 3 over 2 minus 2 over 2, which would give you 1/2. So your answer is 3 over 2 x to the 1/2. If your teacher doesn't like you to write in fractional exponents for whatever reason, you got to convert that to a radical. No problem. X to the power of 1/2 is square root x. Just like x to the power of 1/3 would be cubed root x, okay, whatever this number is in the bottom. X to the power of 2 over 3 would be cubed root x all squared. And that square could go inside as well. Okay, that's just a side note there. And let's see, h, okay, beware here. Don't say 5 times 2 to the 4. No. Why? Because this is not an x, so the power rule doesn't apply. 2 to the 5 is actually a constant, right? It's 32. So the derivative of a constant is 0. Don't get caught up there. And if we have negative numbers, okay, let me do I over here as well. What if we have x to the negative 2? Hey, that's no problem. Take the derivative of that. Y prime is negative 2. X to the, careful, negative 2 minus 1 is negative 3. So without negative exponents, you might want to write it like this, negative 2 over x cubed, because this negative brings this down to the denominator. All right, so that's the power rule. There's some examples. Hope that helps. You're going to use that every day in calculus. Boom.